that same question, right? Still on that same question. We want to solve that question using double integral. We've calculated using line integral. We got 1/6. Now let's solve that same question using double integral. By double integral, we call, what's the formula for double integral? The formula says that double integral r, all into bracket, the partial derivative of q with respect to y, with respect to x, minus partial derivative of p with respect to y, multiplied by what? The a. So what I just need here is what? The partial derivative of q with respect to x, partial derivative of p with respect to y, and I need the limit. You know what this actually means is that I'll integrate with respect to x first, then integrate with respect to y. And whenever you are integrating, you need your limit. You need upper and lower limit, right? Now, let's get these two unknowns first, meaning partial derivative of q with respect to x and partial derivative of p with respect to what? Y. Now, we are given the vector field. The given vector field is what? The given vector field, they are what? P is equals to x squared plus y squared, and q is equals to x minus y. Now from here, say this is 1, say this is 2. From 1, let's differentiate, meaning the partial derivative of p with respect to y. What's the answer? This is 2y. This is 2y. With respect to y, this is the answer. Then for the second one, with respect to what? X. What's the answer? Partial derivative of q with respect to x. That's what? That's equals to 1. You are differentiating p with respect to y. You are taking the function of x as constant, meaning 0. It does not exist. So you are saying 0 plus what you differentiated. This is it. Similarly for this. So this is the answer for partial derivative of p with respect to x and partial derivative of q with respect to what? X. Now substitute what you've gotten. Substitute what you've gotten into your double integral formula, meaning you have integral all into bracket, double integral all into bracket 1 minus 2y multiplied by what? The x, the y. Now the question is, how do I get this limit? You know, when we did when your closed curve was square, we said we got the limit from what? From the vertices, right? Similarly, we are going to get the limit too from the vertices. All right, now we got all the vertices of this closed curve. Okay, we have 0, 0, 1, 0, and 1, 1. Now, just know this. When you want to get the limit, you get the limit of x. Say this is your integral for x, and say this is your integral for what? Y. I get me. Now, you want to get the limit of x, and you want to get the limit of y. You know what it implies? When solving for the limit of x, you need the lower and upper limit. When solving for the limit of what? Y, you need the lower and upper limit. Now, from this closed curve, you know, I said earlier on that it's not necessarily you have this type of closed curve. It varies, different shapes. Now, for triangle, to get your limit for your x-axis, to get your limit for x, you make use of the x-axis, meaning where it is starting, the value of x where it is starting, and the value of x where it is ending. Are you getting me? Now check, for this closed curve, what's the value of x when it is starting? 0. What's the value of x when it is ending? 1. Meaning you have it at this bottom, right? This is x. X here is what? 0. X here is what? 1. Meaning your limit for x, you have 0 to 1. Now what about y? Same idea. Where it is starting, 0. Now to get the upper limit, you get the upper limit using the now take note. Some questions you'll be given y. Let's say you are given that y is equals to, let's say y plus x equals to 1. Where you are going to make use of this is when you need the upper limit of y. meaning make y the subject of the formula. That becomes y equals to 1 minus x. So what this implies is that you are going to use generally for y, the lower limit of y is where it is starting from. As far as this, you have your closed curve as triangle. The lower limit of y is where it's starting from. Then the upper limit, it is the equation of the curve, the equation of the slanted line. You know, from this right angle, from this triangle, this is the slanted line. This slanted line is defining this closed curve. True or false? It is defining it. Now, the question is, what is the equation for y at this slanted curve? When we say equation, we need equation of a straight line. Are you getting what I'm saying? Equation of a straight line. You know, let's say initially the question you have y plus x equals to 1. Y plus x equals to 1. Expected from here, what this is telling is that this is the equation for the straight line. Meaning, make y the subject of the formula. I have that y equals to 1 minus x. Now, in place of this slanted curve, which is where you are going to have your equation, what's the function of y? 1 minus x. You've identified that the lower limit is what? 0, because that's the starting point. 0. Now, the upper limit will be the equation of that straight line, of that curve. So what do you have? 1 minus x. This is when it is given. Are you getting me? But now it is not given. It is not given, meaning you are going to calculate it. So what we are saying is that if they give you x
we use x equals 1 minus y. Do we use 1 minus x for y?
Yeah, like is there a formula to get the function of y? Or what are you saying? Okay, you mean for x, will it be x equals to 1 minus y? Just as for x is always located from this bottom, meaning the starting to the ending. It is for triangle. Yeah, for triangle. For triangle, that's how it works. You'll be giving your function. So give me that function, you won't be told. Meaning we already, they expected us to know it. Meaning from that given function, make y the subject of the formula. And by the time you make y the subject of the formula, what's the tax? It is your upper limit. It is your upper limit. How do you get lower limit? It is where you are starting from. For the y, it is where it is starting from. So the upper limit, it will be this. Okay, now this equation, it is what? It is the equation of this slanted what? Line. Are you getting me? But now for our question, are we giving? No, meaning we are going to calculate. We are going to what? Calculate. Now you calculating, you go back to our normal equation of a straight line that we know. So what we are using here is that y minus y1 is equals to m all into brackets x minus what? x1. Y minus y1 is equals to what? M all into brackets x minus x1. What's m? What's m is gradient, meaning slope. M is the what? Slope. Slope, or you say what? Gradient. M is the slope, or you say gradient. Now, how do you get slope or gradient? By formula, m is equals to y2 minus y1 over x2 minus x1. Now, how do you know x1, x2, y1, y2? From the vertices. So this is what vertices I'm using, or you say coordinate. That would be what? You know, I'm still interested in the slanted part. So that would be what? 0, 0 and what? 1, 1. So this is x1, this is y1, this is x2, this is what? y2. Now substitute. Let's get m. M becomes what? 1 minus 0, which is equals to what? 1. 1 over 1, which is still what? 1. Therefore, m is equals to what? 1. Now let's substitute. Meaning y is equals to, what is your y1?
y1 is
0. Sorry, y minus 0 equals to what? What's m? 1 all into brackets x minus what's x1? 0. Expand this. What do you have? Y equals to 1 multiplied by x. Therefore, y is equals to what? X. Now the upper limit is what? X. Do you understand? The upper limit is what? X. It is not given. The equation of the line is not given. That's why we calculated for each triangle. Yeah, for triangle, you know, square is actually easy. Just now for triangle, this is how it works. I didn't if we were given the equation of the line, I would have used what was given by making what is said of the formula. But in this case, no, for square, the approach of square is not like this. For square, it's actually easier. Meaning that from here, this is the upper limit. So let's write the limit of x and y. For x, what's the limit of x now? 0 to 1. 0 to 1. What's the limit of y? 0 to what? X. Any question? You know how we got this x? The equation of this what? Slanted line, this straight line. If it was given, just make what is said of the formula and substitute. Make use of it in your equation. But if it is not given, you have to solve using this formula. And this formula, m, it is the gradient. How do you get the gradient? Change the y by change the what? X. Since we are working with graph, by the time we trace this is 1, right? This is what? 0. For the x, this is 0. This is what? 1. So for changing y, 1 minus 0. That's it. For changing x, 1 minus 0. Understood, right? Now let's substitute this our limit. For x limit, we've substituted. This is my x limit. 0 to 1. This is it. For y limit, 0 to x, meaning the equation of this curve. So right, once you've solved the function of y, meaning the equation of the straight line, so right, y is equals to what? X. So that's the meaning. Now let's integrate this. By the time you integrate this, you are going to integrate. You integrate with respect. You are going to integrate with respect to what? Y first. Integrating this function with respect to y first. I have y minus 2y squared over 2, right? This cancel out. I have y minus y squared. Now introduce the limit of y since it's integrated with respect to y. What's the limit of y? 0 to x. So substitute. I have x minus what? X squared, right? Minus 0 squared. So this is still what? X minus x squared. Any question? So now integrate this with respect to what? X. Integrate this with respect to x. So by the time you integrate this with respect to x, it implies that integral x minus x squared dx. So let's integrate. What do I have? I have x squared over 2 minus x cubed over 3. What's your limit? 1 to 0. X squared over 2 minus what? X cubed over 3. What's our limit? 0 to 1. Now let's substitute. What do I have? 1 squared over 2 minus 1 cube over 3. Minus, all this will become what? 0. So let's do this. This is 1 over 2 minus 1. What's LCM? 6. 6 go here, 2. This is 3 minus 2, which is equals to what? 1 over 6. So now we solve that question, that particular question using double integral. We got 1 over 6. We solve that same question using what? Line integral. We got 1 over 6. So now from our solving so far, what can you deduce? Does that question verify Green's theorem or not? It verifies. So since the question verifies Green's theorem, it means that integral p dx plus q dy, which is equals to what? S integral p dx plus q dy equals to double integral r, all into bracket, partial derivative of q with partial derivative of what? X minus partial derivative of p with partial derivative of y. A verifies what? Verifies Green's theorem for that particular question, right? It verifies Green's theorem. Verifies Green's theorem. So in some cases whereby your question does not verify Green's theorem, you can still write. But the whole idea is that all right, now up to this level, what this means in general is that the same way we solve for this triangular curve, for this triangular closed curve, implement it to similar questions, you get the same thing. Meaning, yeah, for triangle, the same way we solve this particular question related to triangle, implement it to similar question, solving the line integral the same way we solved and the double integral the same way we solved. You get your answers. So that comes to the end of these videos.